Okay, so we are done with the handouts one, and now we are on handouts two. So we are going to generate some descriptive statistics, and this part is very dependent. So if you are graphing for, or if you are using, a C to Q, the approach will be different from if you are using a C to C or a Q to Q, right? So in my case, all my variables are categorical. So I'm going to be using a, sorry, I'm going to be doing only for categorical variables. So I'm going to be doing just these, right? If you have quantitative variables, then you're going to be doing this instead, right? And then this part will also, because mine is C to C, I'll just be doing this part. If yours is C to Q, you'll be doing this part, or if yours is Q to Q, you'll be doing this part. All right, so I'm going to be doing this part. Now I've already loaded the Descal library. We already know how to use the frec function. We just have to, make them look nicer. So we're going to add all these. So I'll copy this code, right? And there's a reason I'm copying this code. I'll show you briefly. So now when I come here, let's call it descriptive statistics. Now, when you copy the code from this document, right, you realize that the quotation marks are looking funny. This is not how they are supposed to be, right? These ones are not allowed in programming. So you have to change all of them to the normal one. So what you can do is you can just choose replace or find and replace, Control F, and then you copy this, paste it there, and then replace it with the normal one. Then replace all, right? So that it replaces all of them. Right, this one wasn't replaced, so I'm going to just replace it. Now, those ones give you errors, right? Because they're not allowed in programming. Now, this as the ordered, I don't think I need it. So I'll just put my variable. So my data dollar, then I'm not going to use government trust anymore because I'm going to be using final trust, right? So my data dollar final trust. Now, what you can do is, okay, so put the title. So, um, people's perception about whether government is um, doing well to stop the spread of the virus. Right, realize that this is too long, or you can just say the government is doing well to spread the virus. The government is doing well to stop the spread of the virus. Now the names are the labels, right? When I grabbed it over here, you realize that it was agree, disagree, neutral, right? So if you plot, the names will already be there, but then just to there. So agree, disagree, and name them according to how they appear here. And then neutral, or neither agree nor disagree. Let's say neutral. Then the y dot axis percent means I don't want to have counts anymore. I want to have percentages instead. Then the y label is this part. So you can just say percentage of respondents. Then the x axis is the label of the x axis. So these are the perceptions. Then the color is the color you want it to be. I usually don't like adding colors to my graphs, but then maybe blue, right? And I some of you use line shadings. Please avoid that, right? Just use one color unless you want to, I don't think you need to have so many colors, rainbow and all these things. Just something needs. So if I run this, right? So you realize that it's using percentages instead of counts over here, right? So the labels are all there doing nicely, perceptions, da 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 da. Um, Yeah, right. You realize that this bar is in the bar is longer than the y-axis, right? You can do something about it. I think it's called. I'm not sure, but it's a y-lim. So you can have that from 0 is equal to c into brackets 0 and then maybe 60 because it's percentages, right? This one ends at 50. So maybe if I take it to 60, it's going to be okay. I'm not quite sure about the whiling, but let's see. Yeah, so yes, perfect. That works for me, right? So I'm going to do same for all the other variables. So I'm going to do this for gender and then so same thing because they are all categorical. I'm going to be using the same thing. So gender. So if you're not sure, come and run it from here first. Then see female and male. Okay. Right. I was going to type male first, but then drawing it makes me know that female comes first. So I'll just do female. Then I keep it as percentage of respondents, gender or gender of respondents. Let's just say this would be green. Um, let's see. So if I run this, gender is also drawn nicely. I don't like this green, but it's fine. I'll do the same thing for what's it called? Urban dot rural. So I'll copy the gender one, then I'll paste it here, then have urban dot rural. Have this as dwelling. Um, one came first when I drew it. I'm not sure, so I'll just run it again. Rural and then urban. So I'll change this rural area, urban, percentage of respondents dwelling. What's it called? Um, tomato. Then I run this one as well. So okay, looks like the bar is way long, and then this one is not working. So I'll just move this to let's say 70. If I run it, yeah, works perfect. So right, and then you can also come here and see the frequencies and the percentages. Remember that this because it's univariate, right? From the project handouts, it gives you like a frequency function because it's categorical. You use a frequency function and some percentages, right? So you're going to talk about these. So maybe 34.17% of respondents live in rural areas, and then 65.83% of the respondents. Like describe this. Remember, you know how to describe things, right? So yeah, so give a description of these over here. So come and type it in this white space and say maybe 40% of the respondents, like all those things, right? So those are usually the focus, not the code, right? I mean, we need to test your code and understanding, but then we also want you to be able to explain things, because like in industry or wherever you're going to be applying statistics, people will be more interested in the reports than the code that you use to generate a report, right? So make sure you state all the explanations down here. Now, if you're using quantitative variables, then you use this um, summary instead, right? Summary, and then calculate the mean and the standard deviation. Now you draw a histogram. Once you draw a histogram, you know that you have to talk about the shape, the range and all those things, the shape, the spread, and all these things. So make sure you do that if you are doing a quantitative variable. Now there's also CX of names. So for some graphs, these values will be too long, And so you use the CX on names to reduce the size and to make the graphs appear or label the labels appear smaller and so they fit because you don't want to have a missing label, right? So you don't want to draw a graph and then I won't know that this is rural area. You don't want it to be missing. So you can just add a CX on names and then use a decimal value. You can just be switching it up from 0.75, you can make it zero point 0.5. But you also don't want to use something that's very tiny that cannot be read, right? So if it cannot be read, then there's no point, right? So if I use 0.75, you realize that they are looking smaller, but then they are still visible. If you use something really small, let's say zero point 0.2, becomes becomes unreadable, right? And it doesn't make sense to do that. So something that's readable is fine. And then I think there's another parameter called last. And then if you give it last is equal to 2, I think it flips these ones around. But then again, you don't want it to be cut off. So if you realize that, the part of the rural is missing and you're seeing just AL area or, AN area, then don't use the last is equal to 2, right? So, yeah, that's it. Thank you.